Hello guys, you're welcome to Vince Tech class. And in today's tutorial, I'm going to walk you through a comparative analysis of a machine learning technique. Now let's see a little information about our dataset to be used for this project. This heart disease dataset is correlated by combining 5 popular heart disease datasets already available independently but not combined before. In this dataset, 5 heart disease datasets are combined over 11 features, which makes it the largest heart disease dataset available so far for research purpose. The 5 datasets used for its correlation are Cleveland, Hungarian, Switzerland, Long Beach, and StatLog. And furthermore, this dataset consists of 1,190 instances with 11 features. And these datasets were collected and combined at one place to help advance research on cardiovascular disease related machine learning and data mining algorithm, and hopefully to ultimately advance clinical diagnosis and early treatment. This is just little information about our dataset to be used for this project. And this is the documentation of the dataset, which will give you more insights on the dataset. And this is the link to get the dataset. I will leave a link to this dataset in the description section. Now let's move over to the Jupyter Notebook. On our Jupyter Notebook, the first thing we're going to do is to import our necessary libraries. These are necessary libraries to be used for this project. Next, we load our dataset. And this is the location of my dataset, because I've already downloaded the dataset within my system. This is the location of the dataset. Next, we use the head function to view the first 5 rows of our dataset. And if you can observe from the output, this is the first 5 rows of our dataset. Next, we see the shape of our dataset. And from the output, we have about 1,190 observations or instances and 12 attributes or features. Next, we use the info function to get the data type information of our dataset. This is the data type information of our dataset, and if you can observe, old peak has a float type of data type within the dataset. Next, we check for null values within our dataset, and if you can observe from the output, we don't have any null values within the dataset. Now, so we use the column, the heart data.column, to see the features of our dataset. We have the age, we have the sex, type of chest pain, resting BP, cholesterol, fasting blood sugar, resting ECG, maximum heart rate, exercise angina, odd peak, ST slope, and target. That is our target variable. Now we use .any function to see if our instances or observation contain any alphabetical entries. And if you can observe from the output, they are all false, showing that all our observations and instances are all numeric. There is no alphabetical entry within the dataset. Next, we use the value count function to see the distribution of our ST slope. And from the output, 2 is about 582, 1 is about 526, and 3 is about 81, and 0, 1. You can also use the value count function to see other categorical variables. And if you want to further get informed or get more insight about these datasets starting from IE Dataport, just what I said earlier, you can also view You can also go and view the documentation. This is the documentation of the dataset to give you more insights about the dataset to be used or we are using. Next, we use the duplicate.sum. Sorry. Next, we use the duplicate.sum to check for duplicate values within our datasets. And if you can observe, we have about 272 duplicate values within our datasets. So it is always a good practice to check for duplicate values so that it will not interfere with the performance of your model. And we use the drop duplicate function to drop the duplicates, and we are left with 918 observations and 12 attributes. Next, we use the describe function to get the statistical information about our continuous variable. And from the output, we have about, for the age, we have about 918 counts. This is its mean value. This is its standard deviation. This is the minimum value. And 25th percentile is less than 47. 50 percentile is less than 54. And 75th percentile is less than 60. And we have the maximum value to be 77. You can also view for the rest of the continuous variable. This is just the statistical information about our data sets. Now we go over to data analysis, and we use the type of chest pain feature to get to see how the features, the observations are distributed within the data set. And if you can observe from the bar plot, asymptomatic type of chest pain is more on the data set. So people with asymptomatic type of chest pain are more on this data set. Next, we use the value count to check how our target variable is being distributed. For one, we have about 508. That is 508 people are having chest pain, and 410 people are without chest pain. And if you can see, this is 508. This is 410, showing that our data set is balanced. Now, for the bivariate analysis, we use the sex versus the target. You can also experiment with other features to get more insights and inference about the dataset. We can infer from this that male suffer more from heart disease than the female. This is the bar plot, showing that males suffer more from heart disease than the female. Next, we move over to data preprocessing, and we drop the target variable. We use the train test split function to divide our data set into training and testing. And we have our test size to be 0.2. That is 20% of our data will be used for testing, while 80% of our data will be used for training. And we have our random state to be 1. And we use the head function to view the first 5 rows of the training set. And this is the first 5 rows of the training set. Now from sklearn.assemble, we import extra tree classifier. And if you can observe from the output, this is an example of a feature importance. To know which feature contributes more to the prediction of the heart disease. And if you can observe from the plot, ST slope contributes more, followed by exercise angina, type of chest pain, cholesterol, old peak, maximum heart rate, age, resting BP, sex, fasting blood sugar, and the rest. Don't worry, I'll be creating a playlist on feature selection. These are the features that contribute more to the prediction of heart disease. Other lower features are just redundant. You can use feature selection to select the best feature just to get a better accuracy. Next, we use the dummy the get dummy to handle the categorical features. This process is called one-hot encoding. So in machine learning, it's always a good practice to handle the categorical variable. Next, we scale the continuous variable. The reason for this is that most of these features are measured in different units. So it's always a good practice to normalize them, to put them on the same scale to help the machine learning models. You can read more on one-hot encoding, normalization, and standardization to get more insight. Machine learning is an act of experimenting, so there is no golden rules. So we use the head function to view the first 5 rows of our dataset. That is after performing one-hot encoding, normalization, and standardization. This is the first 5 rows of our dataset. Next, from sklearn.metrics, we import classification reports, confusion metrics, and accuracy score. These are performance metrics to evaluate our models, to know how our model is performing. First is the random forest, which gave us an accuracy of about 87%. Next, this is the confusion matrix. You can read more on confusion matrix to get more insight on this project. Next is logistic regression, which gave us an accuracy of about 89%. Next is a decision tree classifier, which gave us an accuracy of 78% or 78.8%, showing that the model is also performing well. Next is the XGBoost, which gave us an accuracy of 88%. And finally is the GNRS neighbor, which gave us an accuracy of about 70%. Also with Gaussian naive bias, which gave us an accuracy of about 89. This is just the comparative analysis of a sample model to know how each model is performing with the IEE datasets. You can also perform hyperparameter optimization using the GridSearch CV to see how the model is performing. And from this, we can infer that XGBoost is a good fit for these datasets. And also with a logistic regression. You can also experiment with other algorithms to see how the model is performing. So guys, that is all for today's tutorial. If you have any question, leave them in the comment section below, and don't forget to like and subscribe to my YouTube channel for more content like this. Thank you.